Now I'm going to explain how the DC power supply works. So first we turn it on, and here we have a voltage reading, and here we have a current reading. So the voltage is the voltage between these two ports, and the current is the current that is leaving through one port and entering back into the other in the complete circuit. Here we have just a very simple circuit. So as I increase the voltage, you can see that the voltage reading increases, and the current increases as well. If I decrease the voltage, then that goes back to 0. Now, as I increase the voltage, the current will continue to increase until it is limited by the current. So if I turn the current knob, right now the current is only allowing 1.4 or 0.14 or 0.13 amps of current to flow through. When I continue to increase the voltage knob, nothing happens because the current knob is limiting the current traveling through the circuit. If I increase the current knob, then the limit for the current traveling through the circuit increases. The voltage does nothing unless the desired voltage does not increase the current above the current limit. So the current decides the final limit, and the voltage does what it can within the range of the current. I hope that makes sense. Today I'm going to talk about how this setup works. I have my DC power supply set to 15 volts. In your lab you'll use 10 volts, but I'm using 15 volts. So that means this positive port is 15 volts higher than the negative port. The electric potential difference is 15 volts. The COM of the multimeter is connected to the negative port of the power supply, while the multimeter probe is plugged in over here. What the multimeter does is it measures the electric potential difference between the input and the COM, and it'll spit out whatever that difference is. So when I put the multimeter probe here, the multimeter reads almost 0 volts. That is because the COM port of the multimeter is connected to the negative, which is connected over here, which is connected to the probe, which is connected to the input. So this is one large equipotential surface, and so they should all have the same voltage, and the potential difference will be 0. If I put the multimeter probe over here, then the multimeter reads 15 volts. That's because the positive port of the battery is connected over here, and the negative port of the battery is connected into the COM. So the potential difference between the multimeter probe and the COM is 15 volts. So the multimeter spits out 15 volts. This is the same potential difference as the DC power supply. Now, if I put the multimeter somewhere in between on the conductive paper, then it'll read the value. It'll read the potential difference between this negative port of the power supply and where the multimeter probe is connected. That is because the COM of the multimeter is connected to the negative port of the power supply, and the multimeter probe is connected to this point, which has its own electric potential. In the lab, you will be looking for electric potential surfaces. To do this, you'll connect the multimeter probe to a point on this paper. Here I have approximately 4 volts. So I will try to find other points with 4 volts. Here we have close to 4, a little bit higher. Here we have close to 4, somewhere in here. All these points form an electric potential line. What you will do is find electric potential lines and plot them on your white paper. Do not place the white paper on top of this black paper. This black paper is conductive, which is why we use it for the experiment. The white paper is non-conductive, and if you were to put that on top, the experiment will not work. Also, make sure that the thumbtacks are connected securely to the metal plates. If the thumbtack is not touching the metal plates or the black paper, then the experiment will not work because the thumbtacks will not be able to conduct electricity into the paper, making it an equipotential surface.